All right, section 11.3 is about conducting a hypothesis test for a test of independence between two variables. All right, so what is a test of independence? So it's used to determine if two variables are independent or dependent on each other. So what does that look like? So here's an example. An article in the New England Journal of Medicine discussed a study on smokers in California and Hawaii. One part of the report involved self-reported ethnicity and smoking levels per day. Ethnicity and smoking levels per day are the two variables of interest. So here's the data. So we have ethnicity here across the top, and then we've got smoking level down here, down these rows. So the columns are different ethnicities, and different rows are different levels of smoking. I think that's probably the number of cigarettes per day smoked. All right. So this data is considered observational data. So this is data that was collected from a survey. This is your sample data. So like goodness of fit, one also needs expected data for an independence test. Now, with goodness of fit, observational data fit in one column and expected data fit in a second column. But you see, these were each, kind of like one-dimensional, right? So they could fit down one list. And expected values, that was one-dimensional as well. But in independence tests, observational data is in the first table and expected data is in a second table. So observational data is now a two-dimensional data set. And I'm trying to figure out where my writing just disappeared to. Oh, there it is. And the expected data is also a two-dimensional table. So instead of a one-dimensional list and a one-dimensional list, you're now going to have kind of like a grid of values. And you're going to have a grid of values. Okay? So this table of ethnicity versus smoking levels, this is our observed data. And then we're going to have another table just like it that's going to be filled with expected data. Now, here's the expected value for this African American ethnicity with this first smoking level. It's 7,778. So how did 7,778 get calculated from all of this? So to calculate the expected value in a certain row I in column J, so this would be row 1, column 1, so that would be like E11, you take the total of the row, so you add up all of the numbers in a row, and you multiply that by the total in the column, and then you divide that by the grand total, so the total of all of these numbers. So for example, the total in row 1 for this first expected value, so the total in row 1 is 98.86, 27.45, 12.831, 83.78, 76.50. Okay, that's row 1. And then that's going to be multiplied all the values in column 1. So 98.86, 65.14, 16.71, and 7.59. So all these values down the column. And that's going to be divided by the sum of all of these values in the table, and that's 100,450. And when you simplify all that, and round it to a whole number, you get an expected value of 7,778. which is where that came from. Now, right now, you may be getting really tense and a little scared and excited, thinking, oh my gosh, I'm going to have to make these calculations for every single one of these cells. And then the answer is no. The calculator is going to do that for you. Okay. Um, and just like you know, like the goodness of fit, to get this test statistic, you're going to be adding up, all of these values. Um, and that'll give you, like a chi-squared test um, using this formula. But the calculator is going to do this for you, except now you're going to have to use your calculator in a slightly different way on the Texas Instruments. MemWorks is a tiny bit easier. On the Texas Instruments calculator, you have to learn what a matrix is. Okay. So how do you set up a matrix and what is a matrix? Okay, the matrix isn't like a computer designed fantasy world, right? That keeps humans enslaved in this interactive computer simulation. No, a matrix is a very typical mathematical construct, uh, which is usually denoted with brackets. And a matrix is composed of rows of numbers and columns of numbers. Almost looks similar like a Sudoku puzzle, right? So if you had a table of data that looked like this, right, 1492, 7250, and 1836, we can represent this table of data, which has 3 rows and 4 columns, as a 3 by 4 matrix, right? 3 rows, 4 columns, 3 rows, 4 columns. And you can see that these numbers ordered in rows and columns are in the same order as in the table. And so this is a matrix. Okay, you see this a lot in linear algebra, for example. Both tables and matrices are arrayed in rows and columns. Okay, the dimension of a matrix is the number of rows by the number of columns. So this doesn't mean 3 times 4. This just means it's 3 rows by 4 columns. It's a 3 by 4 matrix. That's the dimension of the matrix. So on your Texas Instruments calculator, you're going to go to the matrix editor by pressing the blue second button and the X to the -1 key, and then you want to go to the edit menu. Okay, so let me show you what that looks like. So it's going to be the same whether it's a new model or an older one. So you'll notice here, at least on the older model, the matrix is an orange, okay, which means I need to use the orange second button with this X to the -1 power button. With the new models, it's a blue second button with blue lettering. Okay. So what you do is you just click second and this to get to your matrix editor. We want to go to the edit menu. Oops. And we want to edit matrix A. So matrix A is going to have our observed values, and matrix B will have our expected values. Okay, so we're going to edit matrix A. Now notice it's a 1 by 1. So that means 1 row and 1 column. We have to tell it that ours, for example, is going to be a 4 by 5 because we had 5 ethnicities and 4 smoking levels. Okay, so this is going to be a 4 by 5 matrix. And so you'll see as soon as I typed in 4, it gave me 4 rows. And as soon as I hit 5 and enter, it's now giving me 5 columns. Okay. And to kind of note the position my cursor is in, it's telling me I'm in row 1, column 1, and that's equal to 0. So if I go down 1, I'm in row 2, column 1. Row 2, column 2, right? Row 2, column 2. All right. So you have to set the dimensions of the matrix before you start, typing in your numbers. Now, that's what I did already over here on the modern Texas Instruments calculator. Is I went into the matrix editor, went to edit, edited matrix A, put 4 by 5, and I put in all of the values. So these are the columns of my ethnicities. These are the rows of the smoking levels. On the NumWorks calculator, okay, what you're going to do is you're going to go to the Inference app and click OK. Go to Tests, go to chi-squared, but now you're going to do a homogeneity independence test. And you can see here, you don't have to set up a matrix, okay? It just has groups. So I've got 4 rows and I've got 5 columns. And I just went, and I just went through and, oh my goodness, and I just added in all the numbers, okay, and the significance level. So there isn't really anything special to do on the NumWorks calculator, except just go to the correct test and put in your significance level. Okay, but one extra thing you have to do, so now that we've got matrix A defined, here's the thing that most students forget, is let's go back into the matrix editor. You'll notice now matrix A is saying is a 4 by 5 matrix. Now it's going to calculate all the values in the expected matrix for us, okay? But we have to set up an expected value matrix with the same dimensions, okay? So we have to make sure that we go into matrix B, which is going to be our matrix of expected values, okay? Edit menu, B, and make sure you set it with the same dimensions. Okay, now if I go back into the matrix editor, notice our matrix of observed values has 4 rows and 5 columns, and the matrix of expected values will have 4 rows and 5 columns. And, also notice that I left matrix B blank. I'm leaving it blank because the calculator is going to fill that with values. I won't have to do it, but I at least have to set it up with the same dimensions. Don't forget that. Okay. Let me see what I have here. Okay, so I talked about matrices and setting that up. All right. So I think we're at a good place there. So let's come back to our notes. Okay, so this is me just kind of explaining things with the Texas Instruments. Set up the first matrix with your observed values, then go and edit the second matrix to be your expected and make it the same dimensions. Okay, so with matrix A and B prepared, this would be with the Texas Instruments calculator. Proceed with the hypothesis test of independence. So step 1 is our givens. Translate the written claim into a symbolic claim. So this example did not include a clear claim, but it did present 2 variables, which begs a question regarding these 2 variables. Does one variable, ethnicity, affect the probability of the other happening, smoking level? So implying a curiosity about dependence. So our original claim here is that ethnicity and smoking level per day are independent of one another. That means that you can't correlate a person's ethnicity with maybe their smoking level, right? There's no correlation, or actually, yeah, there's no correlation there. Okay. So that's our original claim, and it'll always be that way. So when you find the null and alternate hypotheses, so for tests of independence, it's simple. The null hypothesis is always going to be that the 2 variables are independent. The alternate hypothesis will be that the 2 variables are dependent. It'll always be that way. Okay. Step three is I kind of got this a little bit in reverse, but determine the distribution and draw the figure. So the significance level was not explicitly stated, so we're going to assume a significance level of 5%. Tests of independence are used with a chi-squared distribution. Now, degrees of freedom for tests of independence are calculated using the following formula. So this is different. So degrees of freedom is equal to the number of rows minus 1 times the number of columns minus 1. So remember, we had a 4 by 5 matrix. So the degrees of freedom is going to be 4 minus 1 times 5 minus 1. 4 minus 1 is 3, 5 minus 1 is 4. So 3 times 4 is 12. So we've got 12 degrees of freedom here. The critical value can be determined by your calculator. So we've done this already. The TI-84, you want to use the non-native program that I made called inverse chi-squared 83. With the NumWorks calculator, go to the distributions app and use the chi-squared app for that. Okay, here's two screenshots, two sets of screenshots for the Texas Instruments and the NumWorks. Okay. Regardless of which one you use, you should get 21.03 for a test statistic. So what we've got is we've got our chi-squared distribution. This is actually what the shape of it looks like with 12 degrees of freedom. And our critical value was 21.03. Okay, and the region above the tail, that's our reject the null. And the other region above the confidence level is the fail to reject. So I guess it would be worthwhile just to put significance level of 0.05. That's that area. And this is the confidence level, which is 0.95. Okay. So now let's see where the test statistic falls relative to the critical value. Now, this is where we have to use those matrices that we programmed in. And this is where we're going to use the NumWorks homogeneity independence app or function in the distributions. That should be inference. Let me change that. I apologize. Okay. Okay, so let's do both of these. So Texas Instruments, we're going to go to stat, tests, and we want to go to a chi-squared test. Chi-squared test. All right, so observed and expected. So notice it's got the letter A enclosed with brackets. That's telling you it's a matrix. If you accidentally just type in an A like this, oops, come on now, let me quit. Okay, let me see if I clear that. Okay, if I clear that, okay, it's not even letting me put in an A there. You know, sometimes like students do things and then I can't figure out how they did it. But somehow students have put in like other letters in there. Um, so if you need to get this matrix A back, okay, let me show you how to do that. So you hit second and matrix, and instead of going to edit, use names. And so we want to put A in that spot. So it'll print that A with brackets around it. And the expected, okay, we want it to be B, but let's say we wanted the expected matrix to be C. That's how we would do it. All right. However, that would pose a problem because remember, the expected matrix has to have the same dimensions as our observational or observed values matrix. So we would have to set up C the same way to use it. But I'm going to go back to B. Okay, and we'll hit calculate. All right, we got a really high test statistic with a p-value of 0, okay, which is really eternally tiny. Um, let's now look at the um, NumWorks calculator. So again, I'm going to back up. So we want to go to the inference app, go to tests, chi-squared, homogeneity, independence, put all your values in. Okay, you can use the arrow keys to go to the next column over. Okay, 5% significance level looks good. All right, and then we can go. This is our expected values. Okay, so this shows us what the expected values were. Remember, I told you that first one was 7,778. Okay, it calculated all of them for you. And then here's our test statistic. So 10,301.85 with a p-value 0. Okay, so let's come back over. Okay, so chi-squared test of 10,302 with a p-value of 0. So how does that look? Step 5. Okay, we'll get our results and write our conclusion. So our critical value was 21, roughly, and our test statistic is 10,302. That's way off to the side. So clearly, we're going to reject the null. And the reason why the area was 0 is that it's so minute, so small out this way, it's effectively 0. So that certainly is much smaller than 0.05. Right? The p-value of 0 is smaller than our significance level of 0.05. So we're going to end up rejecting the null here. So the null was our original claim, and we are rejecting the null. So our conclusion is that there is sufficient evidence to support rejection of the claim that ethnicity and smoking level per day are independent of each other. So what this is saying is that um, that some ethnicities smoke more, and some ethnicities smoke less. So there is a correlation between ethnicity and smoking level. Okay, so that's the conclusion. So, a lot of this to save time, I kind of typed in and had this ready to go. But already we've gone through all of these steps numerous times over the last couple chapters. So, I can feel comfortable doing that here. Um, okay, so this was an example of a test of independence and using your calculator functions for this. There are now a couple of think pair shares for you to work through. Um, yeah, let me know if you have any questions.